is Gina V. Alcantara, and welcome to this educational video about electrostatic and capacitors, the important topics in general physics 2. In this presentation, we'll explore the fundamental principles of electric charges, fields, forces, and energy storage using capacitors. We'll start with electrostatics. So electrostatics is a branch of physics that focuses on electric charges that are not moving or at rest. It deals with charges that stays in one place after being transferred from one object to another. For example, kapag kinuskus mo yung balloon sa buhok mo, may mga electron na lumilipat from your hair papunta sa lobo. Dahil dito, the balloon becomes negative charge at kaya nitong maka-attract ng maliliit na bagay like bits of paper. This is an example of static electricity na isang mahalagang konsepto sa electrostatics. To understand electrostatics, we must first look at the structure of the atom. So, an atom consists of protons, neutrons, and electrons. Protons are positively charged while neutrons have no charge. They are both inside the nucleus, while electrons orbit the nucleus and carry a negative charge. So, these are the properties of the three subatomic particles. We need to remember them to solve the following problems later on. So, there are processes of charging. The charging by friction, conduction, and induction. So, there are three processes of charging. First is the charging by friction. When two materials are rubbed together, electrons transfer between them. One loses electron and becomes positive, while the other gains electron and becomes negative. The direction of transfer depends on the triboelectric series. Next is the charging by conduction. When a charged object touches a neutral object, electrons transfer between them. If the charged object is negative, electrons move to the neutral object. If the charged object is positive, electrons move from the neutral object. The neutral object ends up with the same charge as the charged object. And last is the charging by induction. When a charged object is brought near a neutral object, it causes the charges in the neutral object to rearrange. If the neutral object is then grounded, electrons will either leave or enter, permanently changing the object. We've all heard about Coulomb's law, which describes the force between two charged objects. It tells us how the force changes depending on the size of the charges and the distance between them. This law helps us to understand the behavior of electric forces and plays a key role in many areas of physics. So let's dive into how it works. So through experimentation, Coulomb discovered that the magnitude of the electrical force between two charged particles is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. This statement is called Coulomb's law. So mathematically, this can be written as F sub E is equal to K Q sub 1 Q sub 2 over R squared. So ito yung gagamitin natin na formula for getting the Coulomb's law. Under Coulomb's law. So, may isa pang pwedeng gamitin na formula, but this is for the gravitational force. The F sub G is equal to G M sub 1 M sub 2 over R squared. So, in solving the samples, we are going to use this method, the guess method, for us to get the given unknown equation and solution para mas organized siya. Para mas madali rin natin na ma-compute mga problem. So, our first sample number one is two protons are separated by a distance of 4.7 times 10 raised to negative 10 m in air. So, A is to find the magnitude of the electric force one proton exerts on the other. Is this repulsive or attractive? Letter B is to find the magnitude of the gravitational force one proton exerts on the other. So, ito yung gagamitin natin yung F sub G. So, yung letter A, gagamitin natin yung F sub E. And then yung letter B, yung F sub G. So, sasabihin din natin kung repulsive siya or attractive. So, una, given. Ito yung mga given, yung mga distance, yung charge ng proton, and yung Coulomb's constant. Itong Coulomb constant is given na siya. Ito yung equivalent niya is 9.00 times 10 raised to 9 n times m squared over c squared. So, yan yun. Tapos yung charge of proton is given, hindi siya given. So, ito yung naka-table kanina. Ito yung charge ng proton kasi since proton yung given. Ito yung charge ng proton. 1.602 times 10 raised to negative 19. And then yung distance, yan lang yung given kanina dun sa problem. So yung 4.7. The next is yung unknown, yung hinahanap natin, yung A and B. A is for the magnitude of the electric force. And then yung B is for the magnitude of the gravitational force. Next is the equation. Yung letter A kanina is for the electric force. And then yung letter B is for gravitational force. So, halata naman dun sa letter electric force, kaya E to. And then yung G to kasi gravitational, it's for the gravitational force. So, next is to solve. So, yung A muna yung unahan natin. So, yung electric force. So, ang una natin na isosolve dito is tong nasa right, yung charge natin. Pero yung charge natin kanina is yung ito, 1.6 times 10 raised to negative 19. Since isa lang kasi siya, sabi niya kasi dun is 2 proton. Iisa lang naman yung charge ng proton. So, pareho sila. Baka nagpagtataka kayo, ba't sila pareho? Kaya, 2 protons kasi sila. So, dalawa yan. Then, ito unahin natin na isosolve is to multiply both of them. And then, i-over natin dun sa distance squared, which is ito, 4.7 times 10 raised to negative 10 squared. So, ang magiging answer neto is, ito, 1.16 times 10 raised to negative 19, c squared, m squared. So, and then, next is to multiply it to the Coulomb's constant, which is itong nasa left. Yung 9.00 times 10 raised to 9. Ang magiging answer niya is 1.04 times 10 raised to negative 9. Yan yung electric force. And then susunod is yung gravitational force. Ang gagamitin natin na formula is yung F sub G. Kasi yun yung pang gravitational force. So, sa substitute lang ulit natin. Bakit 1.673 yung M na dalawa? Kasi, yung M na yan is the, mass ng proton. Is yung 1.673 times 10 raised to negative 27 kilogram. Pareho lang sila. Kaya, di ba dalawang proton kasi yung given kanina, kaya pareho sila. Then, multiply lang natin yung dalawang mass ng proton. Then, i-over natin dun sa distance ulit squared. So, ang magiging answer na itong nasa right side na to, yung nasa naka-bar, is 1.27 times 10 raised to negative 35 c squared m squared. Then, ita-times natin dun sa Coulomb's the given na gravitational may equivalent kasi yung gravitational constant eh. So, ito, 6.674 times 10 raised to negative 11. Given na, hindi siya given, pero may approximately value siya. Equivalent. Yung letter G, yung nandito, ito. May equivalent siya talaga. Hindi siya given, pero may equivalent talaga siya na value. So, ita-times natin dun sa nakuha natin kanina na 1.27. Na magiging sagot is yung 8.7 times 10 raised to negative 46 n. So, since the both charges are positive protons, the force is repulsive. Diba sabi ko naman kanina na pag hindi ko ata sinabi. Basta pag same sila ng charges, magiging repulsive. Yung force is repulsive. Pag naman opposite charge, the force will be attractive. So, next sample number 2. Two small charge spheres are 0.5 meter apart. One has a charge of positive 2.0 times 10 raised to negative 6, and the other has negative 2.0 times 10 raised to negative 6. So, hahanapin natin yung magnitude of the electrostatic force between them. So, ulit, ganun lang ulit, given, para hindi tayo maguluhan. May distance, may dalawang magkaibang charge na proton. Negative and positive. Then, given lang din yung Coulomb constant. Equivalent na talaga yan. Given na talaga yan. Then, ang hinahanap natin is yung magnitude of the electrostatic force. Ang gagamitin natin na equation is yung F sub E is equal to K. Eto. Gagamitin natin to solve yung hinahanap natin. So, ito. Isa-substitute lang ulit natin yung mga given. Itong nasa taas ng, nandito sa, naka-bar, yung numerator niya is yung dalawang given na charge, positive and negative. Uunahin natin silang i-solve, and then i-over natin dito sa distance squared. So, ang sagot nung, pag minultiply natin yung dalawang charge is magiging 4 times 10 C raised to negative 12. Yan yung sagot. And then, i-over natin dun sa distance squared. So, 0.25 meters squared. And then, after that, wag muna natin galawin yung Coulomb constant. I-solve pa natin tong naka-over. So, 4 times 10 C raised to negative 12 over 0.25 meters squared is equal to 1.6 times 10 raised to negative 11 m squared c squared. Then, dito na natin gagalawin yung Coulomb's constant. So, i-multiply natin dun sa Coulomb constant. Magiging 0.144 n. So, ganun lang kadali. The next sample number 3. Two small identical metal spheres carry charges of positive 5.0 times 10 raised to negative 6c Coulomb and negative 4.0 times 10 raised to negative 6 Coulomb respectively. They are placed 0.2 meter apart. So, yan yung distance. Hinahanap natin yung magnitude of the electrostatic force between them. Ganun lang din. Yun lang din ang gagamitin natin na formula. So, ito ulit, given, para hindi tayo malito. Given, and yung hinahanap natin, magnitude of the electrostatic force. Next is yung equation. Ito lang din gagamitin natin. Kasi since magnitude of electrostatic lang naman hinahanap niya. So, yan lang ang gagamitin natin. This is substitute lang ulit natin. Yung nasa numerator is yung dalawang given na charge. So, yung positive 5 and negative 4.0. Then, i-over natin sa 0.2 meter square. Yan yung distance square. And then, ito na ang ito na yung equals nung dalawang charge. 2 times 10 Coulomb raised to negative 11 over 0.04 meter squared. So, ang sagot nito is 5 times 10 raised to negative 10 m squared c squared. Then, i-multiply natin dun sa Coulomb constant, which is yung 9.00 times 10 raised to 9. So, ang sagot is 4.5 n. Yan yung final answer niya sa hinahanap na magnitude of the electrostatic force. Next is electric field. So, electric field is yung electric field, yun yung Electric force is a non-contact force. An electric charge Q can exert force on other charged object even though they are at some distance away. The space surrounding a charged body is called an electric field. An electric field causes any charged particle placed in it to experience an electric force. Every charge has an electric field associated with it. So, the magnitude of the electric field due to the point charge is, ito yung gagamitin natin na formula for the electric field. E is equals to K Q over R squared. So, sample number 1 is to find the electric field 2 meters away from a charge of positive 5 microcoulomb. So, itong microcoulomb ang tawag dito sa ito symbol na to. Microcoulomb is equal to times 10 raised to negative 6 coulomb. Yun yung equivalent niyang macro na yan. So, first, gawin ulit natin yung given. Given yung distance 2 meters, charge ng proton is yung positive 5 macrocoulomb. Sabi ko kanina, yung macrocoulomb is equivalent to times 10 raised to negative 6 coulomb. Then, given ulit yung coulomb constant kasi yan yung equivalent niya talaga. Next is to find the electric field. Ito yung hinahanap natin, electric field. So, here are the equation and solution for finding the electric field. So, electric field, itong gagamitin natin na formula, yung naka-red. Yung E is equal to K, absolute value of Q over distance squared. So, substitute lang ulit natin. Mauuna pa rin yung naka-bar. So, positive 5 times 10 raised to negative 6 coulomb over 2 meters squared is equal to 1.25 times 10 raised to negative 6 C over M squared. So, multiply natin dun sa coulomb constant na 9.00 times 10 raised to 9. So, ang sagot niyan is magiging 11,250 N over C. Bakit may C? May over C. Kasi, yung nakuha natin dito sa right side is iisa lang yung C. Hindi siya squared. Kumbaga, like, iisa lang siya. Yung square lang dito sa right side is yung M. Kaya, isa lang yung C. Makakancel yung M squared, pero yung C hindi. May matitira na isa. So, kaya N over C yan. Yung unit niya. Next, sample number 2. A charge of 6.0 times 10 raised to negative 6C is placed in space. What is the magnitude of the electric field at a distance of 0.2 meters from the charge? So, ulit yan. Given ulit, distance, yung charge, and yung coulomb constant. Yan lang kailangan natin sa paghanap ng electric field. So, ang hinahap natin is yung magnitude of the electric field. So, equation and solution. Ito ulit yung equation na gagamitin natin. Yung naka-red dito sa left side. So, substitute lang natin. Mauuna ulit yung bar. Ang sagot is 1.5 times 10 raised to negative 4C over M squared. Multiply natin dun sa coulomb constant. Magiging 1,350,000 N over C. Or, pwedeng 1.35 times 10 raised to 6 N over C. Ganun lang kadali. Next, example, a charge of 5.0 times 10 raised to negative 6 coulomb is placed in space. Ganun lang din. What is the magnitude of the electric field at a distance of 0.3 meters from the charge? So, given ulit. Mauna given para hindi tayo magulo. Distance, yung charge lang, and yung coulomb constant ang kailangan natin. Then, yung unknown is the magnitude of the electric field. Equation and solution. Ito ulit yung equation natin gagamitin natin to solve the electric field. And then, sa substitute lang ulit natin, mauna yung nasa naka-bar. So, ang sagot ng naka-bar, nasa loob ng bar is 5.6 times 10 raised to negative 5C over M squared. I-times natin dun sa coulomb constant na 9.00 times 10 raised to 9. So, ang sagot is 504,000 N over C. Or pwede ring 5.04 times 10 raised to 5 N over C. Next is electric lines force. Lines of force have the following properties. Number 1, lines of force start from positively charged particles and end on negatively charged particles, or continue toward infinity. Number 2, lines of force neither intersect nor break as they pass from one charge to another. Next is the greater the number of lines of force, the stronger the electric field. The neutral point is the point where no lines of force pass. The electric field is 0 at the neutral point. Thus, neutral points are points where the resultant field is subtractive and the electric fields are equal but oppositely directed. A neutral point between two like charges is a point between the two charges and nearer the small charge. So, the neutral point cannot be between them. It is an external point along the line joining them and near this small charge. So, ito yan. Electric lines of force. Next is the electric field due to a point charge. An electric field exists in the region of space around a charged object or a source charge. When another charged object enters this electric field, it will experience an electric force. The magnitude of the electric field due to a point charge is yung E is equal to K absolute value of charge over distance squared. So, yun yung gagamitin natin na formula. Sample number 1 is a charge of 6.0 times 10 raised to negative 6 coulomb is placed in space. Find the electric field at a distance of 3 meters from the charge. So, given ulit. Given distance is 3 meters. Charge is 6.0 times 10 raised to negative 6 coulomb. Given yung coulomb constants na 9.00 times 10 raised to 9. Yung unknown is to find the electric field. Bago tayo magpatuloy sa sa pagsosolve ng electric field due to a point charge is ang key difference ng electric field ang key difference of electric field and electric field due to a point charge is electric field can come from many charges like a charge plate. Thus, yung electric field due to a point charge naman comes from a single charge and follows a specific formula. So, parang same lang din sila. Pero may difference lang talaga sila. Pero, dito sa example ko, parang parehas lang din naman sila. So, eto. Ipagpatuloy na natin yung pagsosolve sa solution ng sample number 1. So, ito ang gagamitin natin na equation. Ulit, yung naka-red dito sa left side. Sa substitute lang natin, mauuna yung nasa loob ng bar. Yung sagot ng nasa loob ng bar is 6.7 times 10 raised to negative 7 C over M squared. Times natin dun sa Coulomb's constant. The answer will be 6,030 N over C. Or pwedeng 6.03 times 10 raised to 3 N over C. So, ganun lang katali. Parang ganun lang yung sinabi ko kanina na gagawin natin. Same lang sila. So, sample number 2, a charge of 7.0 times 10 raised to negative 6 coulomb is placed in space. Find the electric field at a distance of 3 meters ulit from the charge. So, given distance, charge, and yung coulomb constant. Ang hahanapin natin is yung electric field. Equation, ganun lang din ang gagamitin natin. Then, yung solution is to substitute na natin yung mga given. Una ulit yung nasa loob ng bar. So, ang sagot ng nasa loob ng bar is 7.8 times 10 raised to negative 7 C over M squared. Then, imumultiply natin sa coulomb constant. The answer will be 7,020 N over C. Or pwede ring 7.02 times 10 raised to 3 N over C. So, next sample. A charge of 6.0 times 10 raised to negative 6 coulomb is placed in space. Electric field ulit, distance of 4 meters. Given distance, charge, and coulomb constant, unknown is to find the electric field. equation, ganoon lang din ang gagamitin natin. Substitute ulit. Nasa loob ng bar ang uunahin. Ang sagot ng nasa loob ng bar is 3.8 times 10 raised to negative 7 c over m squared. Then, i-multiply natin sa column constant. The answer will be 3,420 n over c. Or pwede rin 3.42 times 10 raised to 3 n over c. Next is electric potential. Electric potential is the amount of energy required to move a unit charge in an electric field. So, ang gagamitin natin na formula sa electric potential is V is equal to K times charge or K times Q over R or distance. Pag naman potential difference, often referred to simply as voltage, it is the difference in electric potential between 2 points in an electric field. So, ito ang gagamitin natin na formula sa potential difference. Madali lang siyang gamitin. So, ito yung sample number 1 natin. A point charge of Q is equal to 5 macrocoulomb is placed at the origin. Macrocoulomb is equal to, sabi ko kanina, macrocoulomb is equal to times 10 raised to negative 6. So, ang charge sa problem na to is 5 times 10 raised to negative 6 coulomb. So, ang hinahanap dito is electric potential at a point 2 meters away. So, yun yung distance. So, gano'n lang din, given ulit. The distance, the charge, and the coulomb constant. Hahanapin natin electric potential. Ang equation na gagamitin natin is yung kanina, sabi ko kanina, V is equal to K times Q over R. So, substitute lang din natin. K is the column constant, tas yung Q is yung charge, and then yung R is the distance. Then, yung sagot is magiging 22,500 V. Volts. Volts ba yan? Basta yun. And then, next sample, number 2, is a point charge of negative 10 times 10 raised to negative 9 coulomb is 5.00 meters from point A and 8.00 meter from point B. Find the potential at point A and B. So, ganun ulit, given, pero dalawa yung distance. May point A siya and may point B. Yung point A is 5.00 meters, and yung point B is 8.00 meters. Charge is yung negative 10 times 10 raised to negative 9 coulomb, and yung coulomb constant, ganun lang din. Ang hahanapin natin is yung electric potential. Ang equation na gagamitin natin is yung ginamit lang natin sa sample number 1 kanina, and then substitute lang natin. Coulomb constant times yung charge over distance. Ang sagot ng point A is negative 18 V. Kasi 5.00 meters yung point A natin kanina to. Yung given natin. So, yun yung ginamit natin na distance dun sa point A. Yung point B naman, ang gagamitin natin na distance is yung 8.00 meters. So, ang sagot dyan is, yung point B is negative 11.25 V. Ganun lang kadali. And then, kukunin rin natin yung potential difference itong problem number 2 natin. So, yung V ng point B is i-minus natin dun sa V ng point A. So, negative 11.25 V minus negative 18 V. So, di ba pag yung negative, i-minus natin sa negative is magiging positive yung pag nagkatabi yung negative and negative na sign, magiging positive siya. So, negative 11.25 V plus 18 V is yung potential difference na itong problem number 2 is 6.75 V. Or pwede ring 7. Ganun lang ang gamitin yung potential difference niya. Ganun lang hanapin. Next, sample number 3 is consider a point charge Q is equal to 2 macrocoulomb and calculate the electric potential and potential difference at 2 points. So, dalawa yung distance niya, 1 meter and 3 meter. Given ulit, dalawa yung distance niya, 1 meter and 3 meter. Tapos yung charge of a proton niya, macrocoulomb, 2 macrocoulomb, so magiging 2 times 10 raised to negative 6 coulomb. Given na yung coulomb constant. Ang i-calculate natin is yung electric potential and potential difference. Like yung ginawa lang natin sa sample number 2. So, mauuna yung pag-substitute natin sa electric potential muna ang uunahin natin para makuha natin yung potential difference. So, substitute lang natin. Since dalawa yung distance kanina, dalawa yung magiging sagot natin dito. So, yung first na tawag ng distance is yung 1 meter. So, ang sagot niyan is 18,000 V. Yung second distance naman is 3 meters. Ang sagot niya is 6,000 V. Ganun lang yun. I-multiply mo yung coulomb constant sa charge na nakuha na given. Then, over sa distance na given. Pero since dalawa yung given, dalawa yung magiging sagot natin sa electric potential. And then, sa paghanap naman ng potential difference is to minus the point B or number 2 sa sabihin na lang natin na point A and point B yung distance niya. So, i-minus natin yung point B sa point A. So, 6,000 V minus 18,000 V is equal to negative 12,000 V. So, yun yung potential difference ng sample number 3. May bonus sample number pa tayo. The electric potential at point A is 12V and at point B it is 5V. What is the potential difference between these points? So, ang given is electric potential. So, hindi na natin kailangan mag-solve for the electric potential kasi given naman na yun. Ang hanapin lang natin is yung potential difference. So, ma-minus lang natin yung point B sa point A. So, 5V minus 12V is equal to negative 7V. Yun yung potential difference ng sample number 4 natin. So, ganun lang kadali. Next is capacitors. One important element in an electric circuit is a capacitor. It is a device for storing charges, named after the dielectric material used. Capacitors may be connected in series and parallels. So, mauuna yung capacitors in series connection. So, ang sabi nga dun sa pinakababa dito sa slide na to is capacitors may be connected in series and parallel. Pwedeng series, pwedeng parallel. So, hindi na natin kailangan basahin yung nasa baba. Sabihin na lang natin na if etong nasa image na nakalagay, etong nasa left side niya, ito yung series na tinatawag. Pag naman parallel is yung parang iisang line yung mga capacitors niya. Like ito. Etong nasa left side is yung series. Etong nasa right side is parallel. Then, since ka-series muna ang i-discuss ko, so, para hindi tayo mahirapan na mag-solve. So, ito is for series muna. Two capacitors with 2.0F and 3.0F capacitance are connected in series. So, ang total potential difference of 100V. So, ang hahanapin natin dito is total capacitance, yung charge stored in each capacitor, and potential difference across each capacitor. So, yun ulit, given ulit, capacitor number 1 and capacitor number 2, and yung volt, 100V. Ang hanapin natin is total capacitance, charge stored in each capacitor, and potential difference across each capacitor. Equation 1, diba hanapin natin yung total capacitance. Ang gagamitin natin na formula sa pagkuha ng total capacitance sa series is 1 over C total. So, 1 over C 1 over capacitance number 1 plus 1 over capacitance number 2. So, isa-substitute lang natin yung given sa capacitance number 1 and number 2. Tapos, 1 over 2.0 is equal to 0.5. Ito. 1 over 3.0 is magiging 0.33. And then, i-add natin yung dalawa. 0.5 plus 0.33 is equal to 0.83. Hindi pa dyan nagtatapos. Kasi, need pa natin i-divide, need pa natin i-over yung na-total natin na 0.83 sa 1. 1 over 0.83 is equal to 1.2 F. Eto makakancel lang dito sa nasa right side eh. Yung 0.83 C total, C subtotal over 0.83. Cancel lang yan. So, matitira yung C subtotal. So, parang wala lang yan. Para mas madali is 1 over 0.83 magiging 1.2 F. Yan yung total capacitance ng series. Next is yung charge stored in each capacitor. So, ang gagamitin natin is C total times V total. Yung C total is yung nakuha natin kanina sa total capacitance, and yung V total is yung given na volts. So, ito times lang natin sa 1.2 F times 100V is equal to 100 C. 120 C. So, since the capacitor are in series, Q sub total is equal to Q sub 1 is equal to Q sub 2. Yun lang. Ganun lang kadali. Next is yung letter C. Ano yung letter C kanina? Yung hinahanap natin kanina dun. Yung potential difference across each capacitors. So, ang formula na gagamitin natin dyan is V sub 1 is equal to Q over capacitor sub 1. Yung capacitor number 1. Itong charge na to, 120C, yun yung nakuha natin sa letter B kanina. And then yung 2.0F, yun yung given na capacitor number 1. So, 120 over 2.0 is equal to 60 volts. And then yung isa pang volt, yung isa pang capacitor, yung need natin kunin. So, 120 over 3.0F is equal to 40V, 40 volts. And then, yung potential difference is to add them together. Para makuha natin yung volts kanina na given. Pa yung given natin na volts kanina is 100. So, para ma-sure natin itong na-solve natin is yung potential difference, which is to add both of them. Yung 60 volts and yung 40 volts, magiging 100 volts. So, tama yung nakuha natin tama yung na-solve natin dito. Kasi parehas sila nung given natin na volts kanina ng 100. Ganun lang yung kadali. The next sample number 2 is two capacitors with 4.0F and 5.0F capacitance are connected in series ulit. Total potential difference of 125 volts. So, yun lang din ang hinahanap natin, total capacitance, charge stored, and potential difference. Given, dalawang capacitor, and then yung volt. Tapos unknown, yung tatlo, hinahanap natin kanina, total capacitance, charge stored, and potential difference. Equation, mauuna yung total capacitance, 1 over C total. So, since dalawa lang naman yung capacitor natin, capacitor number 1 and number 2. So, itong capacitor number 1, di ba 4.0 na sa denominator niya? 1 over 4.0 is equal to 0.25. Tapos yung isa naman is 1 over 5.0 is equal to 0.2. And then, i-add natin yung 0.25 plus 0.2. Magiging 0.45. Hindi pa yun nagtatapos. To get the total capacitance of the series is to 1 over 0.45 yung na-add natin kanina, 0.45, is magiging 2.2F. So, yan na yung total capacitance ng series natin. Next is the charge stored. yung C total times V total. C total is yung total capacitance na nakuha natin kanina, and yung V total naman is yung given na volt. So, 2 times 2F times 125 volt is equal to 275C. Since the capacitors are in series, Q subtotal is equal to Q sub 1 is equal to Q sub 2. Yun lang. And last is yung potential difference ng series. Dalawa yan. Dalawa ang need natin na kunin. V sub 1 is equal to Q over C sub 1. So, ito yung capacitor number 1. 275 is nakuha natin yung 275C is yung charge stored natin kanina, yung letter B, over yung capacitor number 1 na 4.0F. So, 275 over 4.0 is equal to 69 volts. Yung capacitor number 2 naman is 275 over 5.0 is equal to 55 volts. So, to get the potential difference of this series problem is to add them together. Yung 69 volts and 55 volts. 69 volts plus 55 volts is equal to 124 volts. Yung volts natin kanina na given is 125. So, close enough lang yung 124 volts and 125 volts. So, that's okay. Next sample number 3 is 2 capacitors with 4.0F and 6.0F. 250 yung volts niya. Tapos, ganoon lang din ang hinahanap niya. 3. So, given, 2 capacitor and yung volt. Unknown, yung 3. Then, mauuna yung total capacitance. Series pa lang to. So, 1 over C total is equal to 1 over C sub 1 plus 1 over C sub 2. So, 1 over 4.0 is equal to 0.25. And yung capacitor number 2 is 1 over 6.0 is equal to 0.17. Add lang natin, magiging 0.42. And then, to get the total capacitance is to 1 over 0.42 is equal to 2.4 F. Yan yung total capacitance ng series. Next is the charge stored. C total times V total. 2.4 F times 250 volts is equal to 600 C. Ganun lang. Last is yung potential difference ng series. So, magkaiba yung potential difference or volts ng capacitor number 1 and capacitor number 2. So, yung capacitor number 1 is 600 C over 4.0 is equal to 150 volts. Yung second capacitor naman is 600 over 6.0 F is equal to 100 volts. So, potential difference is 150 volts plus 100 volts is equal to 250 volts. So, same sila ng given na volt kanina, 250. So, tama yung solution natin. Next is capacitor in parallel connection. Ito yung nasa right sa image. Ito, magkakalinya. So, dito sa parallel, iba ang formula para sa total capacitance and charge stored and yung potential difference. Iba yung gagamitin natin na formula dito. So, to start the parallel, to capacitor, 6.0F, 8.0F. And then, 150 volt. Yan yung given. Tapos, same lang sila ng hinahanap, total capacitance, charge stored, and potential difference. So, given ulit, unknown, hinahanap. Ito, equation and solution. So, mauuna yung total capacitance, di ba? Since hinahanap natin, pag hinanap natin yung total capacitance dito sa parallel is i-add lang natin yung capacitor number 1 and capacitor number 2. Which is yung 6.0F plus 8.0F is equal to 14.0F. Yan yung total capacitance niya. capacitor number 1 plus capacitor number 2 lang yung gagawin lang natin dyan sa total capacitance ng parallel. Next is yung charge stored in each capacitor. So, ang gagamitin natin na formula dito is yung yung capacitor number 1, ita-times natin dun sa volt na given. So, yung capacitor number 1, yung given natin is 6.0 F. Ita-times natin sa 150 volts, magiging 900 C. Tapos, yung pangalawang capacitor naman, ita-times natin sa given na volt, which is yung 150, is magiging 1,200 C. So, yung potential difference across each capacitor sa parallel naman is ganito lang, kasimple. V sub 1 is equal to V sub 2 is equal to yung given natin na volt, which is yung 150. Ganyan lang. Then, next sample. 3.0 F, hindi na natin need mabasahin. Yung mga given na lang na numbers yung babasahin natin. 3.0 F, 9.0 F, and 100 volts. Same lang din sila ng need na kunin. So, given and unknown. Equation is, total capacitance ng parallel is pag-add din lang natin yung capacitor number 1 and capacitor number 2, which is yung 3.0 F plus 9.0 F is 12.0 F. So, yan na yung total capacitance ng parallel. Next is yung charge stored in each capacitor. So, yung capacitor number 1, times natin dun sa given na volt. So, 3.0 F times 100 volts is equal to 300 C. Yung second capacitor naman, times natin dun sa given na volt is 900 C. So, yung potential difference across each capacitor ng parallel is ganito lang. V sub 1 is equal to V sub 2 is equal to 100 volts. Sample number 3. 12.0 F and 7.0 F. 75 volts. So, ganun lang din. Given and yung unknown. Equation, total capacitance ng parallel is to add the capacitor number 1 and capacitor number 2. 12.0 F plus 7.0 F is equal to 19.0 F. Yung charge stored in each capacitor ng parallel is to the capacitor number 1, ita-times natin dun sa given na volt. 12.0 F times 75 volt is equal to 900 C. Ganoon lang din dun sa capacitor number 2. Ang sagot niya is 525 C. Then yung potential difference across each capacitor is V sub 1 is equal to V sub 2 is equal to 75 volt. Yan yung given na volt. And ganun lang. Next is the capacitors in both series and parallel connection. Ito naman yung nagsama yung series and parallel. Ganun lang din ang gagawin natin. So, ang uunahin natin sa pagsosolve ng series and parallel is parallel. Doon mag-focus muna tayo sa parallel. So, ang parallel dito sa given na to is yung capacitor number 3 and yung capacitor number 4. So, ito, given ulit. 4 na capacitor. 2, 6, 3, and 5. Tapos, yung volt nila na 25 volts. Yung unknown, ganun lang din. Total capacitance, charge stored, and potential difference. Equation dito is, diba since sabi ko kanina, parallel ang uunahin natin. So, ang formula ng total capacitance ng parallel is to add the capacitor number 3 and capacitor number 4. So, i-add lang natin. Magiging 8.0 F. Yan yung total capacitance ng parallel. Next is the charge stored. Parallel ulit. So, since ang parallel kasi sa given is yung capacitor number 3 lang and number 4. Yun lang. Ang parallel. So, capacitor number 3, i-times natin dun sa given na volt. 3.0 F times 25 volt is equal to 75 C. Tapos yung capacitor number 4 naman, times natin dun sa given na volt is 125 C. Ang potential difference is V sub 1 is equal to V sub 2 is equal to 25 volts. 25 volts is yung given na volt. Next, pagtapos natin na, after natin na ma-solve yung parallel sa given is, punta na tayo sa series. So, series na to, yung next na gagawin natin. So, ang series dun is yung capacitor number 1, capacitor number 2, and, di ba since parallel yung 3 and 4, yung capacitor 3 and 4, magkasama na sila. Para maging series na silang apat, nagsama na yung capacitor number 3 and number 4. So, ganun lang din, 1 over C total. Ito yung series. So, 1 over 2.0 is equal to 0.5. 1 over 6.0 is equal to 0.16. 1 over 8.0 is equal to 0.125. Then, i-add lang natin yung tatlo. Magiging 0.785. To get the total capacitance of the series is to 1 over 0.785 is equal to 1.27 F. Yan ang total capacitance ng series. Next is the charge stored. C total times V total. Yung 1.27 F na nakuha natin kanina, times natin dun sa given na volt na 25. Magiging 31.75 C. Ganun lang. Q sub total is equal to 31.75 C is equal to Q sub 1, Q sub 2, Q sub 3, and 4. Ganun lang. Next, sample number, ganun lang din. Pero ibang given lang. So, ito, given, and yung unknown. Unahin natin ulit yung parallel. So, C total, yung capacitor number 3 and 4, i-add lang natin, magiging 8.0 F. Yung total capacitance. Next is charge stored. Capacitor number 3, times natin dun sa volt, magiging 300 C. Yung capacitor number 4, times natin sa volt, magiging 500 C. So, yun yung charge stored ng parallel dito sa sample number 2. Next is the potential difference. Ganun lang. V sub 1 is equal to V sub 2 is equal to 100 volts. Yan yung given na volt. Next is, pagtawag natin ng parallel, magiging, need na natin na isolve yung series. So, magkasama ulit yung capacitor number 3 and 4. Kasi parallel nga sila. Sila yung nauna na compute kanina. And then, gano'n lang din, 1 over 2.0, 0.5. 1 over 6.0, magiging 0.16. 1 over 8.0, magiging 0.125. Then, add ulit. Then, 1 over 0.785, magiging 1.27 F. Yan yung total capacitance ng series dito. Next is yung charge stored, yung C total times V total. 1.27 F times 100 volts is equal to 127 C. So, ganun lang. Q sub total is equal to, yung nakuha natin na C, is equal to Q sub 1, Q sub 2, Q sub 3, and 4. Ganun lang. Next, last sample number for the capacitors in both series and parallel. So, ganun lang din ang given niya. Iba lang yung given na number or letter, yung given na number sa capacitor. Pero, pare-pareho pa rin yung mga capacitors natin, kung saan sila nakapwesto. And yung volt, syempre. First is yung given, ibaba natin. I-take down note natin yung given para hindi tayo maguluhan. And also yung unknown, ganoon lang din. Total capacitance, charge stored, and potential difference. Uunahin natin ulit yung parallel. Yung capacitance number 3 and capacitance number 4, i-add lang natin. Magiging 18.0 F. Yan yung total capacitance ng parallel. Next is yung charge stored, is yung capacitance number 3 times natin sa given na volt, magiging 600 C. And then yung capacitance number 4 naman, times ulit natin sa volt na given, magiging 750C. Tapos yung potential difference across each capacitor is ganun lang din. V sub 1 is equal to V sub 2 is equal to 75 volts. 75 volts is yung given na volt. After na parallel, series na tayo. So, magkasama ulit yung capacitor number 3 and 4. So, ganun, 1 over C subtotal. 1 over 4.0 is equal to 0.25. 1 over 6.0 magiging 0.17. 1.18.0 magiging 0.056. Then, i-add ulit natin. Magiging 0.476 over F. Then, to get the total capacitance of this series, 1 over 0.476 is equal to 2.10 F. Yan yung total capacitance ng series. Next is the charge stored. C total times V total. Yung nakuha natin kanina total capacitance ng series, times natin dun sa given na volt. So, 2.10 F times 75 volt is equal to 157.5 C or pwede ring 158 C. Q subtotal is equal to 158 C is equal to Q sub 1, Q sub 2, Q sub 3, and 4. Ganun lang yun. So, that's it. I hope naiintindihan nyo yung discussion ko within those topics. And ako ulit si Shanistrina V. Alcantara. This is my performance task for General Physics 2.